Hello, we are ready for section 3.2, and there's a lot that we're going to learn about in this section. This is a really important topic. It's quadratic equations. It is one of the foundation things that you learn in algebra. So we are going to spend some time here. I think it's going to be 3 videos. So we're going to start by just defining what is a quadratic equation. Then we're going to talk about how to solve one. And there's actually 5 different ways that we're going to learn. And so we're probably going to spend 2 videos, one to get the first couple and then another one to do the last 3. And then finally, we're going to talk about some other equations that we can use because they have some characteristics of quadratic equations. We're going to use what we've learned here to solve those equations. So that'll be the 3rd video. Okay, so let's go ahead and get started, and let's start by defining what is a quadratic equation. So a quadratic equation is an equation. So remember, whenever we hear that word equation, you should be thinking it has an equal sign. It is a one-dimensional equation, which means it only has one variable. We're going to use x. So you can write a quadratic equation in the form of ax squared plus bx plus c equals 0. And I'm not sure why I had a little bit of issues there with the stylus. Let me clean that up a little bit. So a, b, and c are constants in this case. Those are, for each quadratic equation, those are going to be actual numbers. And we're going to require further that they're going to be real numbers. So you can see here with real numbers a, b, and c. And the important thing here to make it a quadratic is that a cannot be 0. Now, why do we say that? What would happen if a was 0? If a was 0, this whole first term right here, if a was 0, we'd have 0 times x squared. It would just go away. And so we would be left with bx plus c equals 0. And again, b and c would be numbers. And that is not a quadratic equation. That is actually a linear equation. If we, and we've already spent quite a bit of time learning about those. Okay, let me clean that up. So for your notes, you don't that green. The definition here of a quadratic equation is an equation that's in the form ax squared plus bx plus c equals 0. You might be given an equation that looks a little different than that at first, but you can add or subtract, multiply, divide both sides to get it into that form. And it has to have that x squared. So x squared is really what you're going to be looking for when you're determining whether or not something is a quadratic. So again, we are going to be learning 5 different methods to solve. Remember, solving an equation means you're finding the values that make it true. There's going to be 5 different ways we can do that. And the reason is you cannot use them all the time. And some are definitely going to be easier in certain cases. Some can be used anytime, but maybe they're a little more complicated. So as we go through, I want you to make note of when you use each method so that, when you're given a problem, you know how to get started. Okay, so let's go ahead and talk about the first method. I'm going to highlight here. I put it in italics when I type this out, but in yellow here, this is the when. This is when you use it. When do you use this first method? It's whenever the b is 0. What is the b up here at the top? B is the coefficient of x, the number that's in front of x. In other words, if that number was 0, what would you be left with? You would be left with ax plus c equals 0. Or, I'm sorry, ax squared. I left off the square. So that b term completely goes away, or that x term completely goes away. You have an x squared term and you have a constant. That's when you are going to use this first method. Okay, I'm going to switch back to blue. So this is called the principle of square roots. And what you're filling in the blank here is if x squared, and I'm just going to use k for the variable, then x is equal to plus or minus the square root of k. This is the principle of square roots. If you know that you can square something to get another number, then you know you can take the square root of both sides. The important thing to remember here is the plus or minus. You actually get 2 answers. So let's say, for example, you know that x squared equals 9. What numbers could x be? X could be 3, right? 3 squared is 9. Or x could be -3 because -3 is also 9. So that's basically that's an example of how this definition works. So if you are given a quadratic equation that does not have a b term, or an x term, you are going to solve for the x squared and then apply this principle. Okay, so let's look at a couple examples. This first one, first question is, does this method work? Does it fit the criteria? Is b equal to 0? In other words, is the x term missing? And it is. There's an x squared term, there's a constant term, and that's it. So we're going to use this method, and to do that we need to solve for the x squared. So we're going to start by adding 20 to both sides. And we get 4x equals 20. And now we are at 4x squared. I'm sorry, I think I left that off earlier. 4x squared equals 20. We're going to divide by 4, and we'll get x squared equals 5. And to solve that, we're going to take the square root of both sides. X equals, and remember, just like up here when we took the square root of 9, we had to remember it could be a positive 3 and a negative 3. We're going to say it could be a positive or a negative. And what is the square root of 5? Well, if you know, you are better than me. It is going to be a decimal. So the exact answer is plus or minus the square root of 5. This is something that came up in the last chapter of sometimes you're going to be asked to give the exact answer, and sometimes you're going to be asked to round. So let's just practice that as we go through the problems today. The exact answer, you leave it as a square root, and if it can't be simplified, you leave it. So if in my math lab you were asked to give the exact answer, it'd be plus or minus the square root of 5. Now remember, that is two different numbers, the square root of -5 and the square root of, or the negative square root of 5. And you may be asked to list that as two separate answers. So if it's two blanks, you're going to write square root of 5, and you're going to write negative square root of 5. That is two different answers. You may be able to use the plus or minus just depending on how my math lab is asking for your answers. If you're asked to round, so let's just practice that. You're going to use your calculator and find the square root of 5. And I'm just going to say round to the nearest thousandth. That's pretty common with my math lab. And just to review, thousandth place means you're going to have 3 spots after the decimal, 3 numbers after the decimal. If it said hundredths, you would have 2. If it said tens, you'd have 1. And if it says to the nearest whole number, of course, you wouldn't have any decimal places at all. And when I take the square root of 5 and round it to 3 decimal places, I get 2.236. And remember, we have 2 answers, plus and minus. So if you're asked to round, this is going to be your answer. And again, it's possible that you'll be asked to list those as 2 separate numbers, which would be 2.236 and negative 2.236. The plus or minus is just a shorthand, but there's actually 2 answers there. Let's do one more for practice. This one looks very similar. We're going to subtract the 27 from both sides. 3x squared equals negative 27. And now divide by 3, we get x squared equals negative 9. And so x is equal to, and don't forget your plus or minus, square root of negative 9. And from the last section, we learned how to evaluate the square root of a negative number. Anytime you have a negative under the square root, that's an I. And then you look at what's left and decide, can I simplify further? So we have plus or minus I, and then the square root of 9 is 3. So we can take the we can just get rid of the square root completely and say 3i. And again, there's plus or minus, so there's a positive 3i and a negative 3i, 2 answers. Okay, so this is method 1, and this is the easiest way if there's no b. So that's the first thing you want to look for when you're asked to solve a quadratic and you're not told how you have to do it. Sometimes you're going to be told solve using, and then it's going to say what way you have to use. But if it doesn't say, and there's no b term, there's no x term, use this. Solve for x squared, take the square root of both sides, and don't forget the plus or minus. Okay, let's move on to method number 2. I'm going to switch my mouse to the highlighter and highlight when we use this. Keyword here is factored. If you can factor the quadratic expression, then you do this. Now, before you can factor, though, it has to be in the standard form that's listed up here, where everything is on one side of the equation equal to 0. So I'm just highlighting that up here at the top. You need to get it into that form first, and then you look to see if it will factor. So this is another one that can't be used all the time, but whenever it can, it does make the problem shorter. So it's good. It's a good one to know. And of course, sometimes you're going to be asked to use this method. If you're asked to use this, obviously you have to use it. But if you're given the option and you can see that it factors, you want to do this. And this relies on the principle of zero product, which says if A times B, remember when we don't have a sign in between two variables, it means they're being multiplied. So A times B is 0. Let's just think about that. If I told you, I'm thinking of two different numbers. When I multiply them together, I get 0. What can you tell me about those numbers? I want you to pause and think about that. I'm multiplying two numbers together, and I'm telling you when I multiply them, I get 0. What do you know about those two numbers? So pause, think about that, see if you got an answer for it, and then I'll come back and then start the video again and I'll tell you the answer. Okay, hopefully you gave it some thought. If you have two numbers that you multiply together and get 0, think of any two numbers. If you multiply them together, 2 times 5, what do you get? You get 10. That's not 0. So you can't, those two numbers don't work. What if you have two numbers that when you multiply them, they get 0? You know one of them has to be 0. There's nothing else you can multiply. There's no other numbers that you can multiply together and get 0 unless one of them is 0. So if I'm telling you A times B is 0, then either A is 0 or B is 0. And that's what goes in our blanks here. A equals 0 or B equals 0. We know that has to be true. One of the two has to be 0. And that is the whole principle as to why factoring works to solve quadratics. And in fact, factoring works to solve all kinds of equations. If you have an equation and you can factor one side of it, I'm talking about equations with one variable. Ours all have just x. There's no y's or z's or a's or b's. One variable. If you can factor them, this principle works. And we're only going to talk about quadratics right now, but this principle works for any equation. If you can factor it, you can solve it using the principle of zero products. And so let's just look at this first one. Notice it's already in the right format. It's set equal to 0. There's only two terms. In this case, we're missing the constant term. There is no c. So we have 3x squared, that's the ax squared, minus 6x, that's our bx, but we have no plus c at the end. So we're going to apply this. It says set each factor equal to 0. So we need to factor it first. And when we only have two terms, it's called a binomial. And this is review. If you need review on factoring, I'm going to make a note to myself now, because that is something that you're kind of assumed to know when you come into this class. So we don't spend a lot of time teaching it, but we use it a lot. So I just made a note to myself. I'll try to link some help for factoring if you're struggling with that. So when you have a binomial, something with two terms, the first thing you want to do is check to see if you can factor anything out. In fact, any kind of polynomial, you check to see if there's any common factors. So when we look at 3x squared and 6x, let's look with the constants first, 3 and 6. Is there anything that goes into both of those? Okay, hopefully you answered me to say 3. You can divide 3 by 3 and you can divide 6 by 3. Now what about x squared and x? Well, both of them have x to the first power as a factor. X squared is x times x, so x is definitely a factor of that, and of course x is just itself, so that works. So we factor out 3x squared. When we factor 3x squared, or we factor out 3x, when we factor that out of 3x squared, we're left with just an x. And when you're factoring things out, you're basically dividing. So we're taking 3x squared and we're dividing by what we're factoring out. And in that case, the 3's cancel and one of the x's cancel, so we're left with x. And then we do the same thing with the minus 6x. We divide that by 3x. The x's cancel completely. The 3 reduces the 6 to 2, so we're left with negative 2. So we now have two factors. We have 3x. Factors mean things that you're multiplying together. We're multiplying 3x times x minus 2. Our rule up here says set each factor equal to 0 and then solve. So we're going to have two things that we need to solve. We're going to solve 3x equals 0, and we're going to solve x minus 2 equals 0. And each of these is going to give us an answer to the problem. So starting with 3x equals 0, we need to divide by 3. And I'm just going to continue up here to the right. The result of that is x equals 0 over 3, or just 0. And then x minus 2 equals 0, add 2 to each side, and we get x equals 2. So we get two answers, 0 and 2. I'm just listing these together. That's not an ordered pair. That's just two answers. And we can check this. Let's plug the 0 in. 3 times x squared, so 3 times 0 squared minus 6, 0. Well, both of those terms are going to be 0, so that works, right? Let's try the 2. This one I'm going to write out because it's not quite as easy to do in our heads. 3 times x squared minus 6 times x equals 0. So I just replaced the x with 2. 2 squared is 4, times 2 is 12, or times 3 is 12. 6 times 2, that should just be a minus sign, is also 12. So 12 minus 12 is 0. So that tells us that the 2 is a correct answer. Okay, let's look at the second example. The second example, notice that I don't have it in the right form. It needs to be in that form where the 0 is by itself on the right side. So I need to subtract 8x from both sides. When I do that, I get x squared minus 8x minus 20. And now I check to see if it factors. This time we have a trinomial, and to factor a trinomial, you want to think FOIL backwards. We would want to check to see if anything factored out, a greatest common factor. There aren't any that factors out. So we're going to think about what are the two binomials that if we FOILed them together, we would get x squared minus 8x minus 20. Well, first times first has to multiply together to get x squared. So both of these have to start with x. And now we look at that last term. What are two numbers we can multiply together and get negative 20? But when we add them together, we get negative 8. So let's just look at some possibilities. What could we multiply together to get negative 20? Well, we could do negative 4 times 5. But when we add negative 4 and 5, we get 1. And if we switched it around and did 4 times negative 5, then we'd just get a negative 1 instead of positive 1. So that's not going to work. What else could we do to get product is negative 20? How about negative 10, positive 2? Negative 10 times positive 2 is a negative 20. When we add those together, we get negative 8. So that's what we want. So our factors here are x minus 10 and x plus 2. So again, if that factoring, if that isn't something that you're real familiar with, or it's been a while, you need some practice, make sure you do the practice factoring that I'm going to post in this lesson. Okay, and if you feel really comfortable with factoring, that's going to be an optional thing. That's not something you have to do. So this first part, we set that equal to 0. X minus 10 equals 0. I solved that by adding 10 to both sides. The second one is x plus 2 equals 0. I can solve that by subtracting 2. So I get two answers, 10 and negative 2. And let's just do a quick check before we move on. Make sure we didn't make a mistake. We go back to the original problem, x squared. So plugging in 10 would be 10 squared minus 20 equals 8 times x, which is 10. So we get 100 minus 20 equals 80. Is that true? And yes, it is. Yes, 100 minus 20 is 80. Let's check the negative 2. In that case, we're going to have negative 2 squared minus 20 equals 8 times negative 2. Negative 2 squared is 4. Subtract 20, we get negative 16, and 8 times negative 2 is also negative 16. So our answers look good. Okay, that's it for this first video. That's the first two methods, and both of these you can only use in certain situations. Our first method you can only use when there is no x term, and the second one you can only use when it does factor. Not all quadratics will factor. So these are the first two methods. come back for the next video to learn the next 3 methods.